You get the double hump, and that's what's going to happen later on when we do SM. So primary substrate, the nucleophile has no problem attacking, whereas when we get to a secondary substrate, it's higher in energy. Why did they not try the tertiary substrate? Because it doesn't happen, right? So we're not talking about, because if it does happen, we'll just say we add more heat. It doesn't happen because the energy requirement is really. So tertiary substrates do not undergo SN2 reaction. So the second thing for a, yes.
So normally you say like there are like reactions that have two steps.
We haven't gotten it. This reaction is always over.
Okay, I just had a question. Like tertiary substrates have two steps.
If they undergo two steps and they do, it's not SN2, it's actually SN2. And they actually go, just to let you know, again, you're asking me questions on the each one. I want to tell you. Actually, SN1 reaction, which is substitution by molecule, which is multi-step, is the opposite of this. Tertiary is better than secondary, and secondary is better than primary. But that's the more. If you're patient, I promise I'm going to cover every. I'm not skipping anything. Alright, so the next thing we need, so one, for a SN2 reaction, we need a good substrate. What's a good substrate? Primary is the best then? Or tertiary? Next thing we need is a good nucleophile. What's a good nucleophile? That's really true. There's so many things about being a good nucleophile. What I'm going to tell you the best advice is you get to see a lot of them and eventually become used to them. But there isn't a one rule that fits all except for a simple one, and that is there are two nucleophiles here. And I already mentioned it. It has to do when you have two molecules, the one that is more
electronegative.
existing between these two, OH minus and H2O, guess what? OH minus is a better nucleophile. But I'm comparing apples to apples. How about OH minus or Br minus? Which one is the better base? OH minus is the better base, right? Br minus is the better nucleophile. But Br minus or OH minus, I'm comparing apples and oranges. That's why I said this is a little tricky. Comparing apples to apples, right? The negative charge is better than a positive. But it doesn't always mean a base is better than. A stronger base is better than a weaker base. Actually, that's not true. It's a little more complicated, even though it's true sometimes. So a good nucleophile, when you compare them, is between two, the negative one is better than neutral. In any case, here's the list of the really good nucleophiles. And notice what they are. Chlorine, bromine, iodine. Now, chlorine, bromine, iodine are really good nucleophiles. But they are also really good healing groups. Right? They're really good healing groups, but they're still also good nucleophiles. These are really good nucleophiles. These, I'm going to circle these. These are good nucleophiles and good bases. Good nucleophiles and good bases. These are weak nucleophiles. Now I'm going to tell you why I circled those. If you have a primary, let's say, if you have a primary substrate, you with me, primary substrate? That means carbon with one carbon. You have a primary substrate. This is a primary substrate. If we have a primary substrate, and you use any one of those 7 strong nucleophiles, all of them will give you an SN. If we have a tertiary substrate and we use any of them, guess what? It's not going to be SN. That's where it gets easy. However, if you have a tertiary substrate and you're using the bases, the action will be Because the base wants a hydrogen, so it will be eliminated. What if you have a secondary substrate? What is secondary substrate? By the way, secondary substrates are the ones that are the trickiest to learn and follow. I'll tell you what. If you have a secondary substrate, if you have a good nucleophile, weak base reaction is SN2. What's a good nucleophile weak base? I minus, Br minus, Cl minus, right? HS minus, RS minus, and NC minus. All good nucleophiles weak. However, if you have a secondary substrate and you have a good nucleophile, strong base, reaction will not go substitution, will go as elimination. So if we have OH minus or RO minus reaction, major product will be elimination. Now give me a second. And please forgive me, I'm not trying to take it easy. I want to go back on slide 24. Go back to this second. So, sorry. Here we go. So remember, this was at the beginning. What kind of substrate is this? Well, it's a carbon, hexachlorine has 2 carbons. So this is a, if you have a secondary substrate, and OH minus is a good nucleophile and strong. If it's a good nucleophile and strong base, the major product will be elimination. And guess what? See what it says here? It says the elimination product is the major product. And it doesn't mean we don't have substitution. We do have substitution, but substitution will be a minor product. So to go back to the slide, and again, you know what, I'm just type 24, pretty easy. Right, so go back to the slide. And this slide is important because the first part, and we have 7 here, 5 of them are really good nucleophiles and weak bases. That means primary, secondary, they'll go as substitution. Whereas OH minus and RO minus, only with primary, they will go as substitution. With secondary or tertiary, they're going to be as elimination. Alright, so we're going to stop on slide number 20.